Hi. During this talk, we are going to talk about YDB. My name is Evgenii or Eugen. To
the center, yeah.
Is it better now? Okay. My name is Evgenii or Eugen. I am developer at YDB, and this talk, as expected, is about YDB. But first of all, I'm going to start the talk from very important things about rumors and our relations with Yuga by YDB. Because actually there are two kinds of people. Some people believe that we, Yuga by YDB and YDB, are exactly the same thing. So Frank and me, in this case, Frank and I are colleagues. Even more, some people believe that once upon a time we had a bar fight. And today, you are going to know the actual truth. And the actual truth, we had never had any bar fight, fortunately. And YDB and Yuga by YDB, despite common characters in our naming, are different distributed databases. And we communicate a lot with each other, and actually we enjoy talking about databases, distributed systems, and getting things done related to benchmarking. So YDB is not just a database. It's not just a distributed database. It's a platform. Originally, we started as OLTP system. But later, because there was a very high demand, we added support for Kafka-like topics servers or persisted queue. And recently, we have added support for OLAP queries. And there are even more projects based on YDB. But mostly, we are known as open source distributed SQL database. SQL database means that we are a relational database. We support OLTP and OLAP. And we are a mature system. We have installations with 1,000 servers. Apache license is expected. If you have a laptop or phone, feel free to go to GitHub and start our project. We are strictly consistent because we take care about developers, application developers, and strict consistency is really important for them. It means that in CAP theorem, between consistency and availability when partitioned, we choose consistency when partitioned. And our transactions have serializable execution. We are highly available and fault tolerant as expected. We support multiple availability zones. Imagine a situation when one availability zone is not available. It crashed. Maybe fire, water, something happened with data center. And also, you lose a rack in another availability zone. In this case, YDB is still read-write available, which makes us a mission-critical database. So we have no downtime for maintenance, etc. And fun fact about YDB, we are not just a cloud-native database. I call this feature of database bootstrappable. We are actually bootstrappable because there are some clouds which are based on YDB. They use YDB to store their metadata. Also, even more, they use YDB to implement their own versions of Elastic Block Store. And finally, they provide YDB as a service. And in this case, when you get YDB as a service, you actually get YDB over YDB over YDB. So it's an infinite number of YDBs. But even more, you might know that inside almost any database there is LSM. Now imagine number of LSMs over LSMs over LSMs. And everything ends in SSD where there is another yet LSM. So let's go to main topic and start from spaceship overview of our architecture. As expected, we are SQL database, so we have tables. And each table has primary key. Primary key can be consisted of a number of columns. And tables are sorted by their primary key. And we split tables into ranges. and there is a partition responsible for each range. Also, we use slightly different naming. For partitions, we use name tablet. Here is our logical architecture. At the bottom, there is distributed storage. Distributed storage is responsible to store all users' metadata and system metadata. Also, it's responsible for redundancy, replication. It's a major component for consensus. And there is a tablet layer above distributed storage. In this case, tablets are reliable components, and they actually implement some sort of database, more like database logic. Altogether, with distributed transactions layer, tablets and distributed transaction implement ACID distributed transactions between tablets, between different tables, etc. But because we are limited in time, today we are going to focus on YDB platform components, distributed storage, and tablets. Most important feature of our architecture is that we separate compute and storage right from the beginning. There are compute nodes which implement database logic. Compute nodes contain tablets, distributed transaction, query processing, and even gRPC. And storage nodes, they provide, as expected, storage. Our system works on share-nothing architecture, commodity hardware, so it's not like spanner. We don't require any special hardware. And separating compute and storage allows to scale them independently. And of course, YDB can be run in virtual machines, in containers like Kubernetes, or on bare metal. This room is for cloud-native databases. Probably I should not say this, but I prefer bare metal because no overhead, it's really better, and no fake machines. Here, illustration about YDB cluster. Usually, each cluster contains multiple databases, and multiple databases, in this case they are called dedicated databases, they share same distributed storage. In really huge installations, there are thousands of databases running in single cluster and sharing a huge distributed storage. This is done for efficiency, to reduce number of resources, because if you have per database cluster, it's really more expensive. Because we are cloud native and even cloud friendly, you can use a dedicated database and share this database with multiple serverless databases. In this case, such a database is called not dedicated, but shared database. Still, storage is shared between multiple databases. So let's dive deeper and have a look on distributed storage. Distributed storage is kind of very special purpose key value store, distributed key value store, and it is used to store immutable blobs. Blobs are of different size. Blobs can be very small, just 1 byte, or 10 megabytes. And tablets, which are located on a second layer, they use distributed storage for two main purposes. First of all, because tablets reliable component, and you might guess it contains replicated state machine, it uses distributed storage to write log records or to read ranges of log records. Also, because as usual, there is log structured merge tree inside tablet, and tablets use distributed storage or blob storage to store standalone blobs, which are actually parts of LSM tree. Blob storage is actually an old title for distributed storage, so I use interchangeably blob storage and distributed storage names. Distributed storage supports multiple redundancy schemes. We support erasure coding. it's kind of very special in comparison with other databases. For example, you can use YDB and install YDB inside single availability zone, and you can use erasure coding to cut your expenses, because in case of erasure coding, you get just 1.5 redundancy, not 3 times redundancy. You don't have to store 3 replicas. And in the case of single availability zone, that's a nice feature, and it works really fast. Why 1.5? Because as erasure coding, we use block 4+2. It means we have 4 parts of blob written to the blob storage with data, and 2 extra parity blocks. More classic scheme is replication. It's the case when you have 3 availability zones or 3 data centers. And in this case, you get 3 replicas, everything is expected. But it's designed in a way that you can add more redundancy schemes depending on your needs. What do I mean by special purpose key value store? Key is a tuple of tablet ID, generation, step, and probably some other things. It's expected from any distributed system. You should have generation, you should have step to solve consensus. Value is a mutable blob. Put and get methods are expected. And I would like to tell you more about a very special method called block. It's used with tablet ID and generation. When tablet wants to become a leader, it uses a block method to say to distributed storage, hey, blob storage, I would like to be a leader. And this is actually kind of it's something in between consensus and election. Actually, it's kind of election part of consensus algorithm. When blob storage answers, okay, tablet, now you are a leader in this generation. Tablet can do useful things. It can store data. Also, another very special thing about our distributed storage is garbage collection. It's barrier-based. So tablets use barriers to collect garbage, and they must move this barrier to tell blob storage that it's time to make garbage collection. Let's have a look on distributed storage node. Each distributed storage node owns devices, block devices, and manages these devices. You might see that there is no file system in between device and YDB. We don't use file system at all because there are many benefits. Main benefit is that we can do our own caching instead of virtual file system layer. Also, here you see that there is a special component called pdisk. Actually, pdisk is a component which manages device. And we can run multiple virtual disks on single pdisk. We have a special scheduler which is responsible to make usage of device fair between different disks. Distributed storage consists of distributed storage groups. Distributed storage group is a thing which is reliable, and it consists of unreliable virtual disks. These groups are managed by a blob storage controller. It's a special purpose tablet which is responsible for managing these groups. I think the easiest way to think about distributed storage, to think about it as distributed array. In my opinion, it is the best intuition about this component. Tablet is located above blob storage group. It uses a special component, distributed storage proxy, which is aware about ways to communicate with virtual disks and hides complicity of using virtual disks. Tablets are attached to one or multiple blob storage groups, and DS proxy is actually kind of API above blob storage group. Virtual disk is an active component. For example, when you lose some virtual disk, and for example, it's away for some time, then you get node back, and virtual disk communicates with others. It's a peer-to-peer system to get all the changes and to make synchronization. So in case of failure, virtual disk will be back, and it will be able to communicate with others within the group to make synchronization. And important feature of distributed storage group is that distributed storage group is not static, it's dynamic. You can easily move a disk from one node to another node, from one device to another device. And distributed storage isolates users because each dedicated database has own blob storage groups, so they are isolated. Usually they share same physical devices, but you can, depending on your needs, you can easily configure a system to not use same physical devices, to not share same physical devices between dedicated databases. So if device is broken and replaced, it's possible to make replication automatically. We have a self-heal process which actually is responsible for this kind of replication. Distributed storage is very scalable because you can scale everything independently. And blob storage controller is a single component, but it's very efficient and doesn't require much CPU. For example, we have cases when we have 10K nodes and everything is okay. Let's briefly overview tablets. Tablets are reliable components and encapsulate stateful logic. They run in compute nodes, and if tablet dies, our infrastructure is responsible to start tablet somewhere else and to restore it in the same state as it was before dying. Tablet contains replicated state machine, and it has LSM, so everything as would expected. And tablets there are different types of tablets, and logic is above RSM and LSM, so it's easy to add new types of tablets. Tablets communicates with blob storage groups via channels. So channel hides complicity of blob storage groups. There might be multiple channels, and some columns can be stored on HDD, and some columns can be stored on SSD, depending on how you use the actual columns. And here is the final slide describing, it actually contains bug. Sorry for this. I'm sorry, forgot to remove extra text. So there is that data shard tablet. It's responsible for row store and row store related SQL queries. We use own YQL language, which is very similar to SQL, but also we are Postgres compatible, almost Postgres compatible. We have column shards. They are responsible for column store. And there are tablets like scheme shard, which manage all the metadata, all the schemes. Very special tablet called Hive, which manages tablets. It's responsible to start, stop, balance tablets. We have coordinators, mediators, transaction allocators, because YDB is originally inspired by Calvin. So it's our similarity with Calvin. And things like cluster management system, sysview processor, etc. Thank you for your attention. Please ask your questions. Feel free to hit me up outside conference. Here's my Twitter. Feel free to ask any questions. Subscribe to me, etc. I will be happy to answer.
Thanks, Evgenii. You mentioned UDB is open source, right? And
yeah,
Apache to license. Is like all stack open source, including blob storage and like pdisk you mentioned? Like,
yeah.
Is all that?
Yes, everything is open sourced, even including SDKs, so all the layers are open sourced.
Would I be able to run it, say, on AWS cloud?
Yeah.
Okay, thanks.
Anyone else with questions for Evgenii? All good? Oh, one more.
Hello, Evgenii. It was nice. It was kind of boring start because I hoped you would tell more about bar fights or something like that. But still, it was kind of impressive. I just have one small question. You said about duplication of that data, like a couple of algorithms to do this. What about deduplication? As far as I remember, you said about key value storage, a kind of simple one. Are you using some kind of deduplication?
To the extent of my knowledge, we don't use any deduplication. So applications can do deduplication on their own.
Oh.
Hello, this is my first time hearing of YDB, and thank you so much for the amazing talk, walking us through it. I would like to ask you, would you recommend that I should be considering using this for my next project, or what is a good environment to consider this for?
Sorry, could you please repeat? It's kind of noisy. I'm sorry.
I was saying that this is my first time hearing YDB, and I was curious to hear from you. Should I consider using this at my next project? Should I consider introducing this to my company? Or is this something that you expect to be really a community thing and inside of Yandex for now?
Well, I think it's really easy to use YDB externally because we have external clients and they use YDB without any issues, and also they checked if they can scale YDB, and you probably would like to check our blog to see performance numbers to understand if it matches your needs and requirements.
Thank you so much.
Thank you for your question.
Any other questions? Cool. Thanks, Evgenii.